Welcome back to Easily Explained, where today we will be talking about indirect variation. So let's get started. Indirect variation, or we also call it inverse variation, occurs when x and y are inversely or indirectly related, meaning that either x is increasing as y is decreasing, or x is decreasing as y is increasing. Usually, more commonly, it's the first option, x is increasing as y is decreasing. But we will look at some more examples of that later on. It is also represented by the equation y is equal to kx. So if you recall, the direct variation equation was y is equal to k times x. So this is basically the inverse, or the opposite of that one, which makes sense since this is indirect variation when x increases as y decreases, whereas direct variation was they both either increase or they both decrease. And again, in this equation, k cannot equal 0. Basically, none of the variables in this situation can equal 0, because if k is equal to 0, then the equation will just equal to 0. Same thing with y. X, if you recall, if the 0 is the denominator in a fraction, as it would be if x was 0, then the fraction will be undefined. So in this case, none of the variables can equal 0. So that's our limitation on this equation. Alright, so now we're going to solve some problems using indirect variation. So in this case, we are finding k for the situation that if 5 people work, the task is completed in 10 hours. So we know that this situation does represent indirect variation because as the number of people goes up, the task is going to be completed faster in less amount of hours. So as x is increasing, y is decreasing. So that's why we can say that this problem represents indirect variation. Now we want to find k. And in the same way, we can use our equation. We know y equals kx. And we could plug in all of the different values for x and y right here, but we can also use the literal equations concept to find what k equals by itself. Isolate it so that it's k equals something. How should we do that? Well, we know that over here, it's k over x. To get rid of x, we have to multiply both sides by x. Here we would get xy. Since x and y aren't like terms, we can't do anything to simplify that. And this would cancel out, because if we look at this and cross multiply, x and x would cancel out, and we would just get k over 1. Okay, so now we know this much more simpler equation that k is just equal to x times y. And we have our x, we have our y. So in this case, k equals 10 times 5. K equals 50. All right, now let's plug that into the main equation and see if it works. We have y is equal to k is 50 over x, and we have y 10 and x 5. That works. 50 divided by 5, 10 equals 10. And so k in this case is 50. Now it's time for your practice on indirect variation. The first one, we have a situation just like the one we covered of an indirect variation example, and you're going to find k when we're given a couple different numbers. They've driven for 6 hours and they have 180 miles left. So you're going to find k. And the second one is a little bit different. You're going to figure out which equations represent inverse or indirect variation, and there might be multiple, so make sure you consider that as you complete the practice. So pause the video now and get started. Alright, number 1. The longer a family drives, the less distance they have left to cover. This is an indirect variation example because as x increases, as they drive for more hours, y decreases. They don't have the distance they have left to cover goes down. It decreases. So now that we know that this is in fact representing indirect variation, we can apply the principles that we just learned. We know that after driving for 6 hours, they only have 180 miles left. So we're going to find k. Remember that our previous equation is y is equal to kx, and we determined by isolating k, we can say k is just equal to x times y. So in this case, we're going to do k is equal to 6 hours x times 180. K is equal to 1080. So that is our constant of variation in this case. Alright, so number 2, which equation represents inverse variation? Select all that apply. Now in this question, the only thing we need to really do is see if they're matching the original equation that we talked about, y is equal to k divided by x. So obviously this is not correct, because if we take 80 as our k and we want to find k, this is not the same as k is equal to xy. This is k is equal to y divided by x. So this is wrong. Also, if you recall, y is equal to kx is actually the equation for direct variation, not indirect or inverse variation. So we can automatically cross that off. All right, for this one, we have y is equal to 40 divided by x, which is y is equal to k over x, which is our original equation because 40 is our k. So B works. It represents inverse variation. All right, now let's try C. X, y equals to 10. If we wanted to find y so that we can compare it to the original equation, even though technically we also simplified this one, but let's just say that we wanted to, y is equal to 10 over x, which is y equals k over x. So C also works. All right, now let's try D. We have x is equal to 90y. So what we want to do all the time is isolate y so that we can solve for y. Y is equal to something so that we can compare it to the original equation. So the way we're going to do that is by dividing both sides by 90. So we can say x over 90 is equal to y. This basically is x over k equals y, which is flipped from the original equation. When in the original equation, it's y is equal to k divided by x. So D does not work either, and your choices are B and C. Congratulations, you are now an expert at indirect or inverse variation. If this video helped, please like, subscribe, and share with your friends. And we'll see you guys next time. Bye!